In the last video, we reviewed the terms used in motion and generated the 5 equations of motion. So in this video, we are going to consider the guides on how to use these 4 equations, on how to use these formulas that we have generated. So we look at what will help us to make the right choice of the equation that we use to solve a particular problem. When using this equation, one must ensure that the units match together. For instance, if velocity is a meter per second, then it means that your distance must be in meter, your acceleration must be in meter per second, the time must be in second. However, if the velocity is in kilometer per hour, the acceleration must be in kilometer per hour squared. Then the distance must be in kilometer and the time must be in hours. Each of the equation contains 4 of the 5 variables. You can see that we have about 5 variables there. That is the time, the velocity, the acceleration, the distance. And remember that velocity of 2, initial and final velocity. And that's what made them up to 5 variables. So what are we trying to say? That you will be given the values of 3 of these variables, and you'll be required to find one or both of the unknown. The best way to select the equation to use is to find out the variables that is not given and the one that you are required to find. Then find the equation that does not contain the variables that is not given but contains the one that you needed to find. And that will be your best equation you will use to solve the problem. Another thing we need to consider is the conversion of units. Take for instance, if we are given our velocity in kilometer per hour and we want to convert it in meter per second, what we need to do is multiply the velocity by 1000 and divide by 3600. What are we trying to say? Just use this formula on the board. You have 1 kilometer per hour to be converted to meter per second. What did I do? I just picked that one, the value of the velocity, and multiplied it by 1000 and divided by 60 multiplied by 60. You know, this 60, that is minutes and seconds. Okay? Converting from hour to seconds means you multiply by 60 and multiply by 60, which will give you 3600. Okay? So whatever the values that it gives you will be in meter per second. So it means that if I am given like 3 kilometer per hour, for me to convert it into meter per second, what I would just need to do is to say 3 multiplied by 1000 divided by 3600, and that will give me what? Meter per second. I hope it's clear. The same way, if I am given meter per second and I want to convert it in kilometer per hour, what do I need to do? I have to do the reverse of what I just did before. This is 1 meter per second and I needed to convert it to kilometer per hour. What did I do? 1 multiplied by 60 multiplied by 60, that is 3600, then divided by 1000. You can see that here we multiplied by 1000 and divided by 3600. But here we are multiplied by 3600 and dividing by 1000. And whatever value is given me becomes the kilometer per hour. Like in this case now, I was given 1 meter per second. Then what I did is to multiply the 1 meter by 60, multiply by 60, that is 3,600, and I divided it by 1,000, and it gave me 3.6 kilometers per hour. I hope it's okay. Okay, let's consider this first question. It said a car moves from rest with an acceleration of 0.2 meters per second square. Find its velocity when it has moved a distance of 50 meters. One thing we have to note in the calculation in motion is that when we are talking about motion, that is the movement from rest, when the motion started from rest, the initial velocity will be 0. And at the end of the motion, the final velocity is 0. Just note these two things. Initial velocity is 0 when it started from rest, when the motion starts from rest. But when at the end of the motion, your final velocity is 0. So in this case now, how are we going to pick the equation that we are going to use? Here, because the car moves from rest, our initial velocity u is equal to 0. Then he said that with an acceleration of 0.2 meters per second, it means that our a is 0.2 meters per second square. Then he said find its velocity when it has moved a distance of 50 meters. It means that our distance here now is 50 meters, and the final velocity is what we are looking for. So, just as we have said, which of the equations contains the three variables that were the three variables given that we are required to find? In this case now, we are required to find one of the unknown. In that case, what we need to do, this is v squared is equal to u squared plus 2as. That is the equation that will fit for this. So what we use now is v squared is equal to u squared plus what? 2as. You can see that in this case now, this is the one we are looking for. This, we already know this, we know this, and we know this. So there is nothing to give us headache here. Let's just go for substitution. So where we see u, we put the value of u. Wherever we see a, we put the values of the a, and the s, the value of the s. So in this case, we will have, okay, so we have 0 squared plus 2 multiplied by 0.2 multiplied by 50. 0 squared, of course, is 0. Then we have 2 multiplied by 2 multiplied by 50 gives us 20 meters per second. So when this square goes to the other side, it will change to square root. So we have that v is equal to the square root of 20 meters per second, and that gives us 4.47 meters per second. Let's consider the second question. The second question says a car has a uniform velocity of 108 kilometers per hour. How far does it travel in half a minute? What we have to do, the first step we have to take here is to convert the kilometer per an hour into what? Meter per second. Let's go. Okay, that is it, and it gave us 30 meters per second. Now what we have to do is to bring out our data. We have that the velocity is equal to 30 meters per second. Then what are we looking for? We have the time, so the half a minute, and that half a minute we have to convert it to second also. Remember that a minute is 60 seconds. So it means that half a minute will be 30 seconds. You can also use the formula to do that. So it means that what? our t is equal to 30 seconds. Then what we are asked to find is how far does it travel? That means we are looking for the distance. So in this case now, which equation do you think we will use? We are going to use the first equation. The first equation said that distance is the average velocity multiplied by time. But here we are not talking, we are only giving one velocity. So what we are just to do is to say that the distance is equal to v multiplied by time. And that will give us, our v is 30, the time is 30 seconds. Okay? And this is meter per second. So in that case now we have 30 multiplied by 30 will give us 900 what? Meters per okay, this is per second. That is per second multiplied by second. So per second, remember that per second is the same thing as 1/second. And since we have second there, that means multiply by second. Second will now cancel second, such that we have that 900 meters. Okay. Now, let's look at question number 3. A car starts from rest and accelerates uniformly for 5 seconds until it attains a velocity of 30 meters per second. It then travels with uniform velocity for 15 seconds before decelerating uniformly to rest in 10 seconds. A. Sketch the graph of the motion. B. Use the graph to find the acceleration during the first 5 seconds. Deceleration during 10 seconds. The total distance traveled. Solution. We have to start by sketching the graph of the motion. In sketching the graph of the motion, what we need to consider is, where did it start? Is it at a given velocity or at rest? He said that the car started from rest. That is from the origin. And let's assume that our origin, okay, let's have like a velocity time graph. If here is 0, then it means that here should be something like 10, 20, then here should be what? Here should be 30. Okay, now let's go. He said it started from rest. It means it started from 0. And he said it accelerates uniformly. So it means it goes like this. It's accelerated in this form until it attains a velocity of 30 meters per second. Okay. This is the velocity of 30, isn't it? As it attains the velocity of 30 meters per second. For 5 seconds. At this point now, it means that this is at what? 5 seconds. Here is what? 5 seconds. Okay. Then he said it then travels with uniform velocity. So with this velocity it has attained, it traveled uniformly. So at this 30 meters per second, it travels uniformly. For 15 seconds before decelerating. Okay, let's assume it has covered what, 15 seconds. Then before decelerating, then it decelerated. Can you see? So it means that from here is what, 15 seconds. Deceleration took place after 10 seconds. So if here is 15 seconds, here is what, 10 seconds. Decelerating is coming down, retarding. Are you getting it? So we have finished sketching the velocity time graph. We have sketched the graph of the motion. Okay, the next question says, find the acceleration during the first 5 seconds. We know that we can use equation to solve this, but we were asked strictly to use what? The graph. He said using the graph. It means the person didn't want you to use equation to solve it. That is the graphical method. Remember, we can solve in motion. We can solve using equation. We can also solve using graphical method. Now, the graphical method is what we are going to use here, because that's what we are asked to use. So we have that BI. He said the acceleration during the first 5 seconds. The first 5 seconds is here. This is the first 5 seconds. And what is acceleration? This is a place. This is accelerating uniformly. So this is the point of what? Acceleration. So how do we get it? So our velocity, this area is the velocity, because this from here to here is this. That is from here to here is from here to here. That is the 30. From here to here is 30. And then from here to here is 5 seconds. So I want to bring out that graph. So I will have something like this. This is exactly what we have there. So here is 30 meter per second. And here is 5 seconds. Okay? So acceleration here will now be, this is the acceleration A. So this A now is equal to here divided by here. So we have 30 divided by 5 seconds. Remember that this is meter per second. Okay? So in that case now we have that 5 into 30 is what? 6. Okay? Now let's look at our units. This unit, meter per second, means meter divided by seconds multiplied by 1 over seconds. This seconds here. So in that case now we have 6 meter, because 6 times meter is meter, times 1 is 1. 6 meter. Seconds times seconds. Remember, this is per, that is slash. But if I want, I use that to power minus 1. Okay? So seconds times second will give us what? Second square. That is per second square. And that is it. That is acceleration. The second question then says deceleration. Find the deceleration during 10 seconds. Remember, here is the acceleration, here is the deceleration. So it means we are still going to do what we did at the other side. Now, here is the side we are calculating. Means that this place is equal to here divided by here. Okay? Now, let's extract the parts of the graph there. Let's extract this graph. And that is exactly what we have just done. The dotted line, the decelerating position, and the 10 seconds. So here is 30 because it's still at the same level of the 30 meter per second velocity. Okay, so in that case now, the deceleration there is equal to here divided by here. 30 meters per second over 10 seconds divided by 10 seconds. Okay, in that case now we have, this is the 30 divided by 10 meter per second. Okay, here we have 3, right? Now let's look at the units we have. This is what? Meter divided by, that is multiplied by 1/seconds. Okay, so that will give us what? M multiplied by 1 is M. Okay, second multiplied by second is second square. Okay, so it means that the answer is 3 meters per second square, or we can equally write it in this form. Okay, that is the answer. You can equally write it in this way or in that way. Okay. The next question says the total distance covered. In this form, finding the total distance covered simply means finding the area of the shape. And remember that this is what? Trapezium, isn't it? Okay, what are we going to do? Let's use the formula of the area of the trapezium. We have half, then open bracket, this length here plus this length here, bracket closed, multiplied by the height. Let's put it down. So half AB plus BC multiplied by H. In that case now, AB is this side, here is A, AB, then here is what? B, and here is C, such that you have AB, that is from here to here, plus from here to here, then multiply by the height divided by 2. So our AB, B to A is what? And that is from here to here, and that gives us what? 15. So we have 15 plus here to here is what? From here to here is 5. 5 plus 15 is 20. Then 20 plus 10 is 30. Remember, we have half. Then the height is this. You trace the height here. That is 30. So 15 plus, open the bracket. That is, do the bracket first. 15 plus 30 will give us 45. Okay. Then multiply this 45 by 30. This 30. So we have 450 multiplied by 3. 0, 15, 1 carry 1, 5 carry 1, 12, 13. Okay, and that gives us what? 1350 divided by 2. Okay, so 2 into 13 will give us 6, remainder 1. Place the 1 in front of 5 to become 15. 2 into 15 will give us 7, remainder 1. Place the 1 in front of 0, it becomes 10. 2 into 10 will give us what? 5. So it means that the distance covered is in what? The units. Remember, here is in meter per second, here is in second. So the distance covered is what? 675 meters. Because meter per second, the second divided second will give you 1. And 1 multiplied by meter is meter. And that is it. Now try this one.